So, welcome to an evening with Andy Duncan, take two. When we did this live on Friday, the 26th of February, with over 100 attendees, unfortunately, there was a big problem with the Zoom recording. And there was some technical glitch, which actually meant it didn't actually record onto the cloud as planned. So we've had apologies from Zoom. But for members who couldn't attend the live session, we've always promised that we would make sure that there would be a recording after the event. So I'm very, very grateful to Andy Duncan, who's agreed to do a rerun for us of the session. And he's with me. I'll be the chairman for the evening. So I'm Jackie Neeshaw, the chairman of events. And Tony Kell is with us as the co-host. So brilliant. Thank you again, both of you, for doing a rerun of this. The questions and answers and explanations will be as close as possible to the first evening. And we hope that all of you who watch this video from wherever you are in the world will enjoy it as much as the guests who were here on Friday night. Before watching the video, you should have already seen Andy's original video about how a kit is produced. And during that video, he showed us through the whole process of creating a master from a model, from brass kits, making the mold, then casting all the bits, and then making it basically into a kit. Andy managed to produce that video during lockdown, and I wanted to make sure that I say again, thank you to Andy for doing that, because it was a mission in itself. It worked very well, and I'm sure people have enjoyed that very much. So tonight we're going to be able to ask Andy some questions, many of which were sent in advance about the whole process. And I'm going to make a start with those, if I may, Andy. So okay. Welcome.
Okay, thank you.
I'm going to first of all switch you on to Spotlight, which means that basically you will stay on screen for the whole duration, even if Tony or I are speaking. So you should now appear large on everybody's screen so that we can see exactly what you're trying to show us as well. Okay. The first question, if I may, was basically going back to the very start of the process. You talked about the fact that you measured, for example, the shepherd's hut, and then you needed to make the master from which you were going to cast the kit. That whole making a master part, is that basically scratch building? Is that what you start with?
Yeah, I mean, basically what you've got to do is, first of all, you're going to have an idea of what you want to do. And then you really need to find an actual object, whether it's a shepherd's hut or an animal or whatever. And then you need to get some decent photographs and decent measurements. And then basically you sit down, do yourself a little drawing, and you've got to break it down into its component parts. You know, if you're going to make a shepherd's hut, you'll need the sides and the ends and the wheels and the underframes. And basically, you've got a pile of brass bits and pieces, just normal bits of brass that you buy from any of the brass suppliers, little bits of bar, bits of sheet, bits of all sorts of things. And you just cut it and make it and solder it, and you end up with parts of a shepherd's hut. And they are scratch built. They are made from pure blank pieces of brass, and they end up in the shape that you want them to be. And as it is pure and simple scratch building.
That's brilliant, thank you. So when you go down to the casting shed and get ready to make the mould, how do you choose between a rubber mould and a silicone mould? Because we saw both, yeah. And I just wanted to be clear about why you choose one over the other.
Basically, vulcanized rubber molds are probably the best way of doing castings from, because the rubber goes off nice and hard, and you've got decent patterns. If you've got really good patterns that you've made out of brass and you've soldered them all up together, they'll stand quite a bit of temperature and quite a bit of pressure, because when you make a mold, it goes under a lot of pressure, and it's heated to anywhere between 150, 200 degrees. So you need to make sure that your masters are going to withstand the mold making process. And a rubber mold gives very good definition, but there's so many different variations of rubber, from very soft to very hard. And they're all usually supplied mainly to the model business in 9-inch molds. That sort of size.
Yeah.
Which is a standard 9-inch, what I call an F9, which is supplied by a company down in Faversham. I can't remember the name of the company now. But there's 2 or 3 people in the country that will supply a blank rubber mold. And it basically comes in a pair. You get a top and a bottom. One's just a blank, and the other's got a hole, or you've got a middle bit that you've got to push out, and it just gives you a hole in the middle. Now, if you're making patterns with, shall we say, milliput for animals, or sometimes you can get patterns actually made from 3D printing. If somebody makes you something 3D printed, it's some sort of acrylic, plastic, whatever they call it, resin, and you can actually use that as a pattern. Milliput will stand a vulcanized rubber mold, but usually when you make a mold with milliput, when you take the master out, you lose it. It just disintegrates because it's been under pressure. But you get the impression to start with, which is no problem at all. And if you're using a silicon mold, it's a lot less temperature and it's a lot less pressure. So it doesn't damage your pattern so much. And you can use, shall we say, more fragile bits and pieces. If you've got some little bits and pieces that are, shall we say, very fragile, and some of these bits and pieces, and when I say fragile, you get something like that.
Yeah.
And that's an operating lever from a traction engine. And when you've got little bits and pieces like that, any pressure will bend it and distort it. So you need to keep bits like that and put them in silicon mold so that you get a really nice straight casting from the pattern. The only problem with silicon is the molds don't last so long, and they're a little bit more expensive, and they're very prone to cracking like cheese if you're not very careful. With a rubber mold, you can bend it and twist it and do it like with it, throw it against the walls, no problem at all. But you've got to be a little bit more careful with silicon. So basically the difference is rubber molds are the standard. If you've got a good brass or white metal bits, you can make patterns out of white metal, aluminium, anything like that you can make. It's not too much of a problem. Anything fragile or a bit delicate, then you use a silicon mold. But again, there's 3 types of silicon mold. There's a medium, soft, and a hard. There's a cream one, a grey one, and a red one. And I usually use the grey one in the middle, and we're quite happy with that. And that's basically how you decide on which mold you're going to use.
Okay, that's really helpful. How long does a mold last then? Because you mentioned about them cracking and breaking. If you were using, say, a rubber mold, if you mentioned that that's one of the most common ones, how long would you be able to use that for?
Well, a rubber mold, I mean, it's the same old story. If you don't abuse it, it'll last you for a long time. A rubber mold, I know it sounds a bit odd, but I mean, the metal that you pour into a rubber mold can be anything up to 350, 400 degrees. And the trick to it is not to keep running the same mold over and over again. When you're casting, once you start your procedure, you usually have about 6 or 8 molds all stacked up, and you go round in a circle so that when you cast the first one, the metal goes in and you put it at the bottom of the heap, and it sits there while you cast the other 6 or 7 molds, and it gradually cools down. And by the time you get to pick it up, you know, you can actually handle it, because if you watch the video, you know, you're the old hot burnout business because everything's blooming hot. But the center of a mold if I can find the one I'm looking for. The center of a mold is that piece there. And the metal comes through the hole in the top of the mold and it hits that. And as that's spinning, it throws the metal up the spokes. And over a period of time, that'll actually go hard. There's your hole in the middle. Pour the metal through the plate. This is the plate off of the top of the casting machine. That's sat like that. Pour the metal through the middle of that. It goes down into the middle of the mold and then it goes outwards with a centrifugal force. Now, every time you do that, that mold gets blooming hot. If you just carry on casting, the middle part starts to go very, very brittle and then it cracks. And the cracks creep up the feeds to the bits and pieces. And you get all sorts of problems. Then it's just a case of you've got to scrap it and start again. Silicon molds, you've got to be a little bit even more careful of because it's a softer material. And they don't last so long. But rubber molds in general, if you use them sensibly, shall we say, you talc them, you let them cool down, and you store them properly. Because if you see in the video, all my molds are all stacked on their edge. I mean, most people stand them up like a stack of sandwiches, but if you do that, that's the worst thing you can do with rubber molds because the weight will distort them. When you store the mold on its end, so it's stood upright, because it's very, very important that rubber molds stay flat. And it's in the mold making process that you've got to make sure that the mold is flat when you make it, because what you don't, when it runs, you want it to be dead flat. You don't want it to be doing that. And if you stack one on top of the other, the poor mold at the bottom's got all the weight on it and you get all sorts of distortion. And when you start casting from it, you'll find that your castings are bellied out and they go all sorts of peculiar shapes. But I've got molds that I've had for probably 20 years. And obviously some molds you use a lot more than others. But most of the majority of my molds, I think in the last sort of 20, 25 years, I've only ever had to replace probably 10 out of about 500 or 600 molds. And as long as I say you use them sensibly, they'll last you for years.
Brilliant. So I want to go to putting the masters into the rubber before it's vulcanized. So I know you showed us that the blank, if you like to call it a blank, was quite soft and rubbery, funnily enough, before you actually put the bits in. Presumably, when you put that in the vulcanizer, the rubber heats up and then the masters are going to sink into it a bit. So how can you make sure that it sinks in the same depth on either side? Because it's going to go into the bottom, it'll go into the top. Do you have to press it in place first, or is it about the pressure in the vulcanizer?
I'm afraid I haven't got any blanks here with me because they're up in the flipping casting shed. But the blanks are like licorice. They're very, very soft, and it's just a blank rubber. And you can get an impression in it by just pressing your finger into it. So when you make a mold from the rubber, you put the rubber on the heating plate on the vulcanizer so that you heat the rubber up more or less to the temperature that you're going to vulcanize from it. The hotter it gets even softer. So when you've got the bottom, shall we say, ready to put your patterns in, you just push them into the mold so that they're roughly halfway. As long as they're in the mold, they seem, for some peculiar reason, to sort themselves out. If you've gone all the way around when you put your bits and pieces in, if you've got something like these things like this, I mean, these are axle boxes and then you've got springs. And if you push that in the mold, you'll find that all these bits and pieces, they'll sort themselves out so that they settle in the middle. And because the mold is pressurized, because you jack it up with the platen on the top and the bottom, you jack it up together and it squeezes it together. And the rubber then goes into every nook and cranny. And that's why the steel platen that you make the your mold out of is such a precision piece of steel that there's very, very little crack in it anywhere, no join. So the rubber will actually go in to the join around the steel. And when it comes out, when you take the mold out, you've got to trim it off so that when the pattern is in the mold in between the two, it's got a nice temperature, it's quite happy, it'll mold itself around whatever you've got. And then while you jack it up, it sits there quite happy and the rubber will form into every nook and cranny. And that's why you're supposed to use really good mold so that you get a good definition, so you get a nice casting of what you've done. Mm. But they basically seem to sort themselves out. But with a mold, if you've got a mold, which are the standard 9-inch mold, that's how deep a mold is.
Yep.
That's the edge. So when you're making a pattern, you've got to make sure that it fits in this gap here. If it's too big, obviously, it's going to come outside the mold and you'll just make a mess of it. So all your patterns have got to fit in that little gap there. It's probably only about an inch and a half. And there's different ways you can make patterns. If you've got like a big lump, shall we say something's in an L shape, not that way, but that way, and you've got a bit that sticks down, the rubber blanks are in layers. I don't think you can actually see them. Once they've been vulcanized, you can't see them. But all that in there's about 8 or 9 actual layers of rubber. And they're all laid one on top of the other. And then they're stamped out into a big circle blank. And if you've got a pit that you want to make sure that goes down into the bottom, you can actually mark round it and then cut it out with a scalpel. And you can pick out the layers so that the piece actually sits more in the bottom than it does in the top. But what it will do is it will find the horizontal plane and it will choose that as the part line, and that's how it will form itself.
Excellent. So if it's like licorice and gets very hot and quite soft, how come the two halves don't stick together when they're heated up in the vulcanizer?
That's where the old
talcum powder.
The old talcum powder comes in. You'll find that everywhere is there's talcum powder everywhere in the casting shed because it does go everywhere. But it's very, very critical that you talc everything. The blank, when you've got it heated up, you put it on the platen, it comes out and it's hot. So you cover it in talc and just brush it all off so that the thing is covered in talc. Then you put your masters in, and then you put your locators in, and then you talc the other side. And then when you put the top on, it goes together, and it's the film of talcum powder that stops it sticking. But you've also got to make sure that you do the edge of the blank, otherwise it will stick to the platen. So you've got to cover everything with talcum powder. I mean, a lot of people use French chalk and all sorts of dust, but I like to smell nice, so I use me imperial leather. And it's the same when you're casting. Once you've made the mold, when you take it apart, you talc both sides. Once you've taken the patterns out and you've got your mold made, then you've got to cut all your feeds. You talc everything again, and then you cast it. And while you're running, every time you're running a mold, the first thing you do is a little brush, and it's a short stumpy brush, so that you just dust it over both sides, give it a smack together so that most of the dust goes. And in my casting shed, that's why I always work in the window, because talcum powder is a bit carcinogenic. You're not supposed to breathe it in. So you want to try and get most of it to go out the window. But that also helps the metal, shall we say, to slide up the sprues. So it's talcum powder, basically.
Oh, brilliant. You mentioned about the rubber, and obviously it contracts a bit when it actually gets hot. Do you have to oversize the masters to allow for shrinkage?
I don't generally have to worry about it. Again, if you use good quality rubber blanks, good quality rubber, and you've got a good pattern, you'll get a very, very little shrinkage. You will get a slight amount of shrinkage. But if you've made, shall we say, like a shepherd's hut, and you've measured it for 12 foot, you've measured everything to exactly the size that you want it, so that everything shrinks to the same degree. So if you say you've got 0.5% of shrinkage, the wheels, the chassis, the underframe, the sides and everything will all shrink to the same amount. So once you get the kit out, it's not as if you've got one bit one size and another bit another size. They're all the same size. And sometimes it's very, very difficult to pick out whether you've got a bit of shrinkage. But again, we go back to the type of rubber that some people use. If you use a really soft rubber, you know, you can get all sorts of strange things happening. You know, you get the centrifugal throw will make one side thicker than the other because the rubber is softer and it'll allow more metal, and it will push the metal, push the rubber apart. So you can get all sorts of weird things going, but the ones that I use and the metal that I use, because of what it is, it's very, very good, and I don't have to worry too much about shrinkage.
It's really interesting. It's a vulcanizer. Obviously, we saw you put the mold in, the soft mold in, and then jack it all up. How much pressure goes into that, and what sort of temperature do you reach? And if you leave it on for too long, can you overcook it?
Yeah. When you're vulcanizing, that big platen that you saw in the film was, I mean, it's a blooming great heavy lump of steel. You don't want to drop it on your foot, because once it goes into the vulcanizer, it just sits there. And the basic only thing that will move is the two, top and bottom, will come together, and it creates a pressure. And it usually seems to, I don't know quite how it works, but it exerts the same pressure top and bottom. Now, the jack underneath my vulcanizer, and I suppose I've been doing it for so flipping long now, I can jack that up so that I feel how much pressure I've got on it. And sometimes it's like when you're jacking it, because there's no gauge on the thing, when the whole thing starts to rock and you press the jack down, if it starts to rock, then I'm somewhere near it. But it's just years of experience, that is. And the temperature is anything with a rubber mold. You'll put it in the vulcanizer, and it'll vulcanize for anything up to an hour. But on the vulcanizing machine, there's a timer. So you'll set the two temperatures, top and bottom, so that they're equal. And then you'll set your timer, and then you can get on and do some casting. And it'll run for 3/4 of an hour or however long you set it for, depending on what you've got. And if you've got great big lumps, you know, it'll take a bit longer. If you've got little bits, it will take a little bit less. And you can get on and do a bit of casting. But when you come to take it out, it should have all gone together quite happily. Now, if you was to leave it in the machine, and you went to bed, got up the next day, you go up the shed, you'll find everything's cold because the timer would have switched it off. And that's the critical bit. And that was the shame about the film, that I couldn't show you how to make the mold as such. Because once you start, you've got to go through the whole process of making the mold while it's hot. So once the timer clicks off and you're in the casting shed stood next to it, that's when you start making the mold. You take the platen out, you open it out, you take the mold out, and then you pull the two halves apart. You take out all the patterns all the way around, and then you've got yourself your old Harry Scrave surgical scalpel. And that blade is the sort of blade that, if you look at the dimension from the end of the bar to there, is an ideal length and strength for cutting the V's either side in the mold. But it's so easier to do it when it's hot, and you need to do that straight away. So you've got the bottom of the mold and you start cutting your feeds. And once you've done the bottom half, that blade will be nearly blunt. So you've got to take that blade out, put a new one in to do the top half. Now, if you left it and went cold, yes, you can do it, but you'd struggle a lot more because the rubber would just bite on the blade, and you'll be pulling and pulling and pulling to try and get it to go through. And the trick to it is to get a nice smooth slice. And when the vulcanizer is finished its time, you've got a nice hot, soft rubber mold ready for cutting. Because as it cools down, it hardens. Mm. And that's how you, I mean, I don't really know what the pressure of that jack is, to be quite honest with you. But I just know that when you jack it up, that if you look at the side of it, the lid doesn't actually go down onto the ring. It sits proud of it a little bit. And the jacks the two together so that when you take it out, there's no gap. It's gone down flat. So you know that it's vulcanized.
Brilliant. You've preempted the next questions, and I have to thank everybody for sending these questions in advance. There's too many names to mention, and particularly as we're rerunning the evening, but there were several people who said, how do you cut the channels to go out to the actual pieces of the masters that you want? And how on earth do you get them to be a mirror image from the top and the bottom, so that when you cut the channel, a mirror for the liquid metal to go down?
Well, this is the critical point about making the mold. When you make the mold, this is where you've got to concentrate. And as I said, it's the sort of thing that once you start, you've got to go through the whole system, get it all cut, top and bottom, all up together, nice and happy, so that you're getting a production run out of that mold. Now, the mirror image is another thing's difficult to show you. All the molds, when they go in, we have what we call locators that go all the way around the outside. Usually put about 6 or 7 in, and they're these little things. And that's the bottom. Okay. And you can see it's got like a lip on it. I mean, you can buy these things, but they're made of steel. These I cast myself. These are white metal locators. And that's my locator mold. And you can see all the locators in there. So when I want some mold, when I want some locators, I just cast the mold. But when you put the bottom blank in the platen, when you put your masters in all the way around, and then you put these, you just push these down into the mold all the way around, and the rubber forms around underneath that lip so that it can't come out. Mm-hmm. And once you've got them in, that's what makes the locator sit in exactly the same hole every time, so that when you vulcanize it, it's vulcanized so it can't go anywhere else. So when you put the top on, one half's got locators in. Yep. And one half's got a hole in it.
Yep.
So wherever you put it, and on my molds, I usually cut a little notch out of there. That's the bottom half with a notch in there. So when you put the two together, you haven't got to keep going round and round and round to find out where it goes. You put the two notches together, and that's it. The locators are now holding that in place.
Yep.
And it won't go anywhere. Now, when you're cutting the feeds, this is one of the, shall we say, one of the skills of the job, if you like. I've got a big horse here. Now, if you look at the feed there, there's a flat piece like a V. And where you've got the bottom of the horse's hoof, you've got to cut it that way. So you get like a ramp. At the bottom of the horse's hoof, there, there's a ramp that goes up and it's flat.
Yep.
But when you cut the V's are cut, difficult to show you. But what you've got, you cut the thing at an angle. From that ramp, a slice comes back, and then you do the other side, and a slice comes back. So that the bottom of the mold, when you cut it, has got a V like that. Mm-hmm. And you've got to make sure that where in the middle of the platen, where that big mushroom went, you've got to make sure that you cut the gates through there. As you can see, they're all fed into it, so that when the metal hits this, this is what starts it spinning, and it's got to be able to flow up the V from there through that bit. And when it gets to the end, you've basically got what's like that, two ramps. The metal comes up and it goes through straight into your pattern, or the void that's been left by your pattern. And basically, when you do the top, you cut the same again. The top's got a V in it, and the bottom's got a V in it. So that basically you've got like a triangle, a top V and a bottom V. And they will always go together in exactly the same place. And the crucial thing is when you've got the new mold, when you cut it in that slice, it comes back in a nice smooth side. And when you talc that, talcum powder is so fine, that's what actually helps the metal go up that diamond shaped hole, if you like, or up the tube or the spoke or whatever you want to call it, so that when it gets to the end, it's got no choice but to go in the hole that you've made where your pattern was. And that's how you keep the two together, and that's how you cut the feeds.
So when you've cut the feeds in the bottom, how can you be sure that the feeds are going to be in the right place on the top one?
Right. This is the trick to, as I was saying to you just now, about making sure that you do the mold. Once you start, you've got to keep going. So that when you've done the bottom half, you take the patterns out, you cut all your feeds in the bottom half all the way around, and you look at it. Yeah, I'm quite happy with that. Give it all a cover in a talcum powder. Brush it all over, dust it off. The top piece has now got exactly the same holes for the locators, and it's got the other half of your castings where you put the masters in. So now you've got to make sure, like you say, you've got to make sure that the V, the top V, is in exactly the same place. So you actually put the thing together, put it in the casting machine, and you actually spin it and cast it. And when you take it out, if you look at that one there, look, can you see here, I've not cut. I haven't cut the other side. This is the top piece. I haven't cut these. Some of these have been cut. Mm-hmm. But if you don't need to cut the top ones, these are gauge 1 loco bits, wagon bits, and they're quite meaty, but the majority of the time you'll need to cut both. But what's happened there is, because you've talced the top piece, and the metal's actually run up here, up the V, and it's marked the top side. So if I needed these buffers, if they wouldn't cast and I needed to cut these V's, all I do is just follow those lines with a scalpel and put the top V in. And that's how you get an identical top and bottom feed. They just follow each other, because once the talc's on, the mold's nice and hot, because when you're doing this, the mold is hot. It'll mark the mold and it makes it so much easier. You just follow the lines.
Yeah, yeah, it's created a pattern for you, really, hasn't it?
It does, yeah. And of course, new blade every time, job done.
Excellent. Yeah. Got one more before I hand over to Tony. And again, it was a very, very common question. How many channels do you have to cut to each item?
Well, again,
on some of those molds you've been showing us, some bits have just got one channel,
yeah,
and others have got several. So
right.
How many do you have to do to which?
It just depends on what you're actually casting. I'll go back to this one. If you see on that one there, the majority of these have got one feed.
Yeah.
That thing there is a sprue. This is a brass pattern there. So that went in as a pattern with that piece in it. And I've just cut a feed there, look. But because it's splayed out, in the bottom part, I've recut that one. I've cut another feed there, look, and another feed there, so that that feeds and that feeds. Yeah. That one there has got a big feed, and then you just cut one to each break block.
Okay.
Yeah. And when you get something like, a horse like that, obviously you're going to need a feed here for that leg, a feed there for that leg, and just one in the middle so that it marries up. Yeah?
Yep, got you.
Now, some of these molds, if you look at this one, this is the top of this one. Where's the other one of that gone? Because this is the other way around. Where's the bottom one of that gone? I've got so many flipping molds here. Lost it. I'll show you on this one. Everything's got a feed there.
Yep.
Now, because this is a spring, on the end of that spring there's a little piece. If I get it up right so you can see it.
Yep.
There's a little piece, a little plate that goes on the end.
Yep.
And that bit is pointing downwards, this little bit here. And when the mold is spinning, the metal goes up the spring and it'll go into the top bit, but sometimes this little bit at the bottom won't cast because it's going back the wrong way. So then you cut another little feed to it, to the bottoms of those little plates.
Yep.
So depending on how many bits of it you need that won't cast, you just cut a little feed to it. And when you're doing, if you take this thing, this is a mold with crane hooks in it. And this is the bottom piece where the metal hits. Again, the feeds have been cut through gates. And then you've got your feed. And then you've got all your little feeds coming off here. But if you look at that, it's like a Catherine wheel and everything's going that way.
Yep.
Because when the metal spins and flies up this feed, it's going that way. If I put those hooks this side, they wouldn't cast. So everything's got to have a throw on it, if you like. Even that thing, that's a column, it's got to go that way. So when you're cutting your feeds, if you've got some awkward shapes, and I mean, we do get off, here's a ladder. This is a classic example of ladder. So do you put the ladder in the mold like that? Or do you put the ladder in the mold like that? If you did that, you'd probably have all sorts of problems because it wouldn't cast. So when you put it in the mold, you put it in like that. So you have a feed to this bit, and you cut a feed to that bit. So you have two feeds. One lot goes up the top bit, one lot goes up the bottom bit because it's throwing that way, and that'll cast every time. And this is one of the little tricks and bits and pieces that you learn with this sort of thing, is how to put things in a mold and where to feed it from. Mm-hmm. Because you've got to imagine that everything is going outwards that way. So if you've got anything hanging down here, the metal's going to go straight past it. So you cut a little feed from the center to the bottom of it, and it'll just carry the metal up itself, and it'll fill in all your little bits and pieces. So really it depends on, I mean, if you've got this blooming thing, and I mean, it's so flipping small, I don't expect you can see it. That thing.
Yep. That's really fragile.
It is very, very fragile, but you've got to feed it in there. That's got an insert in there because there's two pieces. It's very difficult to show you because it is so small, but the insert goes in there.
Yeah.
And it's fed so that these two prongs go that way. But I've got to have a feed to that little handle, because the handle's going in the opposite direction. It's going in the opposite direction to the other bits. So when you make a pattern, you look at it and you think, I'm going to need to feed that, and I'm going to need to feed that.
Yeah.
And then when you test it, that's when you find out whether it will feed. One of the peculiarities of it is if you're doing wheels, if you see like you're making cart wheels, shepherd's hut wheels, you make one pattern. You only ever make one. I know you need four, but you make one pattern. And once you've got your pattern, it's perfectly round. So you put it in the mold and you cast it. And what's happened is, because of the centrifugal throw, the top half goes slightly oval. And it may be slightly thicker, but I mean, it's minuscule. So that you'll run that mold 4 times, so you've got 4 wheels. And then when you put them in the production mold, you turn the wheel round so that the feed now that you've just used is at the top. And you put a new feed in the bottom. So that when you spin it, the centrifugal throw goes the other way, and it brings the wheel back round again.
Right.
Very clever.
Very clever.
But I mean, you learn that from the first time you do it, you don't do that, and you make all 4 wheels the same, and the whole thing's going up and down the road because none of your wheels are round.
Andy, I've just thought of one more thing, because you mentioned there about the sprue and that you might have to solder bits on the master before they go in the vulcanizer. How come it doesn't all fall apart if you've soldered something?
Well, again, if you're making patterns, you've got to be a little bit careful with patterns. You've got to make sure that if you solder something together, that you're using a higher temperature than what you're going to vulcanize it at. Mm-hmm. So if you're vulcanizing at 150 degrees, you'll need to use at least 188 degree solder. So that when it goes in the mold, it doesn't get hot enough, because the thermostat on the vulcanizer will click in and out at 150, whatever, 140. It doesn't get hot enough so that it melts your solder. Yep. I mean, I must admit, I have tried this in the past. Somebody sent me some figures, and I said, what are these made of? Oh, they're made of white metal. I said, all right, okay, brilliant. What he hadn't told me was he'd used 73-degree white metal solder to put them together. So I put them in a mold and vulcanized it all. And when I opened it up, I just had one hell of a mess. Because all the white metal had melted, and some of these blokes were 4 foot wide and about 2 inches. Bloody right mess. And these sort of things do happen. I mean, if I'm using, especially when you make these sort of things, when you make fiddly little bits like that, you know, you've got to use at least 188-degree solder to make those and make sure that it doesn't fall apart. If you're doing, if you want to make something like that, I mean, that's the roof for a roller. And you've got to make all that in brass to start with.
Yeah.
And as you can imagine, you're going to need a lot of heat to put that together. So you're going to know that the vulcanizer is going to be 150, 160, whatever you're vulcanizing at. That is going to need to be at least 188. Now, I'll probably make that out of 240-degree solder with a 100-watt iron. And the pattern, the brass pattern for that is made with 240-degree solder and 100-watt iron. And I know that it won't come apart.
Yeah.
So when you put it in the mold, it won't even shift.
That's really helpful. Thank you. I'm going to pass over to you, Tony, if that's okay.
Okay then. Good evening. When you're moving on to the casting process, why doesn't the hot metal melt the rubber?
That's a good question. I don't know, to be quite honest with you. I mean, rubber is rubber. You can do all sorts of things with rubber. When you put the metal into the mold, you've got to, the mold's hot to start with, because sometimes when you start your casting process, the first 2 or 3 or the first couple of spins, because the mold is cold, you won't get a complete set out. Some bits will be not cast because the mold's not up to temperature. But once you've vulcanized that rubber, it seems to go hardish, and it seems to be quite happy. I mean, I've never had a problem with any of the rubber molds. I know other people have had problems with a very softer rubber. If you've got a softer compound, then you can get problems by pouring blooming great lumps of hot metal in it. But the center of the mold, where you pour the metal through the big plate on the top of the casting ring, when it goes into the mold, it hits that dish, that little disc bit in the middle, and the metal's on its way up the tube. So it's dissipating the heat as soon as it goes in. And that's why when you've got your melting pot going, you've got a stainless steel ladle so that it doesn't stick. Stainless steel, white metal won't stick to stainless steel, it just runs off. That's why you've got to have stainless steel. But of course, you've got to have a wooden handle, otherwise you're back to your old hot burnout jobby when you pick it up. And you leave the ladle in the metal. So the ladle is at the same temperature as the metal in the casting pot. So that when you scoop it up, you pour it through the hole in the machine when it's spinning, and off it goes. And it will burn it, as I said before. If you just use that one mold, it would just get so blooming hot, it would bake it crisp, and it would be just like crunchy. And it's the vulcanizing process, it seems to be quite happy to take that sort of temperature.
Thank you. We mentioned about this ladling the metal into the mold. Many people have asked, how do you know how much metal to pour in?
Oh, 25 years of experience. When you've got the ladle in the machine, you've got the machine going, and when you're putting the molds in, I mean, I have made mistakes where you've got something that's got, if you've got a mold full of horses, that's quite a bit of metal to fill all that lot up. And then sometimes you'll have a mold that's got a lot of little bits like that, where you don't need so much metal to fill all them little bits up. So when you're doing it, you know roughly what the mold is that you've put in, and you ladle out some metal. It doesn't really matter how much you've got on in the ladle, but when it's spinning, if you look down through the top of there, you'll be able to see can you see that?
Yep.
The hole in the top of the mold.
Yep.
Yeah. So when that's spinning, it's going around at a fair old rate of knots. If you look in that hole, you'll see a silver ring appear on the inside, down in the mold. So while you're pouring it, you'll see it, a silver ring will start to appear. And that's when you stop. Because once you see that silver ring, you know that that metal is in the middle of the mold. You don't need any more.
Okay.
Sometimes if you get it wrong and you're not really concentrating, you pour it in and it goes in and it comes back out again. It comes over the top, makes a hell of a mess in your casting machine.
And then you spend a long time cleaning it.
Yeah, you spend hours cleaning the plumbing thing, but there's no sort of measurement or any sort of gauge that you can use. You just know that, you know, if you're doing horses, you want a good old dollop, wallop it in. As soon as you see that little silver ring, you stop.
Thank you. Obviously, as the metal goes in, it displaces the air inside of the mold, but where does the air go to?
A lot of the time when you're casting, you don't have a problem for some bizarre reason. I think because you've got the diamond shape, the metal goes up, the air just seems to dissipate out between the two joins and between the top and the bottom. But you can get what we call feedback or heat back. And if you look up the end of the feed, you'll see that the end of what you're trying to cast hasn't cast, and it's very shiny. And what happens is it pushes the air and it traps it so that the air can't go anywhere. And it stops the metal filling that little part of your master. So what you do, there's a couple of things you can do. When you get something like that, if you find that that little top bit is not casting, you just cut a little feed like that. You cut like you're cutting these channels, you cut a little feed from there, same way as the flow, but you don't come right to the outside, because if the metal goes up, it will just spray out the hole. But when the metal comes up here, it goes up the casting and it pushes the air into that little bit there. Make sure that then that it casts.
Do you ever have to drill holes into the mold to release air that way?
You can drill holes in it. I mean, sometimes if you've got a bit that's facing down, the metal comes along and goes down, that will trap air because it's down in the mold. So you get yourself a little hand drill with something like a 1 mil drill in it, and you just drill through the bottom, so you've got a hole going down. When the metal goes in, it pushes the air down into the hole that you've made in the mold. It's a very, you don't get that very often, actually. Most of the time, it's actually getting the metal to feed into the cavities that you've got in the mold. You don't get a great deal of problem with air trapping, but you do get it, and that's the way to get over it.
Thank you. So this metal that you use for the mold, what materials go into the metal? Do you have to mix it, or do you buy it ready mixed?
Now, I didn't bring the blooming casting bar down. Casting metal, all white metal is the same, more or less the same. It's tin, lead, zinc, cadmium, bismuth, antimony. And the majority of it is all the same, but in different quantities to make different types of casting metal. Now, casting metal goes from really cheap recycled lead off the church roof right up to pure tin pewter. And there's about, I don't know, 50 or 60 different grades in between. But the majority of the stuff that we use for what we use for model making is, I mean, I use 3 different types of casting metal, and it comes in a kilogram bar, and it's 34.5% tin. And it's basically what you look at is the tin content of what you're using. Now, 34.5% tin in a 9-inch rubber mold, the way that we do things, will give you a really nice representation detail-wise. It'll give you a nice smooth finish, and it's not too much of a problem. Now, I also use what they call KA, which is from 35% tin, it goes up to something like 48, 50% tin. Obviously, it's a lot more expensive, but it's got a better quality and it's got more tin in it. Now, if you were making a mold like that, or a mold like that with big lumps in it, it's not too much of a problem. 34.5 tin will do. If you add a mold, and some of them are, back to our little bit and piece, if you had a mold with a lot of them in, I would put some Ka in the pot so that I've increased the tin content so that the tin will help that cast. So that when you put the mold, when you put the bar of metal into the pot, you've got to have a big hot pair of gloves because you'll heat it up. And then you've got to stir the pot, because if you leave it, there's about, I don't know, 15, 18 kilos in a melting pot. And over a period of time, you know, bits and pieces settle at the bottom. So if you stir it when you put it in, it mixes it all together, and it also helps all the dross, what we call dross, float to the surface, because you do get a bit of contamination in it, but you just skim it off. And it's the sort of thing that the temperature, don't ask me what the temperature of it is, because casting metals are peculiar. They've got these temperatures. It's like white metal solder. If you use white metal solder, it's exactly the same tin, lead, zinc, cadmium, antimony, bismuth, but in different quantities. And you've got different melting points. 73-degree solder, if you class it and you look at it, it'll come out as 73.33 eutectic. That's its specification. And basically what that means is when it gets to 73.33 degrees, it's not a liquid and it's not a solid. That's its eutectic temperature. And all these different cast metals and solders have all got what they call a eutectic temperature. But it's different quantities of the tin, the lead, the zinc, the cadmium that makes the different types of casting metals. Because if you go up to things like pewter, it's, you know, it's blooming, they're all tin. And I mean, if you add pure tin, well, it would be pure tin, cost you an arm and a leg. But that's why pewter is so expensive, because it's got a very high tin content. And then if you want some really special stuff, there's another metal that I use is 60% tin, but I use that for some of the contract casting bits and pieces that I do. I used to do shell bearings for the old, you remember the old strap down bonnet Bentleys, the straight six Bentleys?
Oh, yeah.
Well, there used to be a chap over at Shaftesbury. He used to do these. He was a restorer of these things, and he couldn't get any white metal bearings, these half shell bearings that go in the cranks. And he asked me if I could do them. And I said, well, have you got a pattern? And he said, well, yeah. And I made him a mold. Again, this is another thing that you can do, is to double the size of your thickness of your mold by taking a new one apart and putting extra layers on it to make it thicker. And he supplied me with some metal, which he said was white metal, for these white metal bearings. But if you hit it, it rang like a bell. And you think, blimey, what the hell is this made of? It was as hard as hell. And I had to melt that. Like that one up there was probably 350. It was nearly 500 degrees to get the blooming stuff to melt, to make these shell bearings. And it is purely and simply just white metal, but there's so many different grades of it. And some of the people that in the model business don't use you know, good quality stuff. I mean, if you look at some of the kits that are on the market and you look at some of the castings, I mean, some of it is really nice, but there's some awful rubbish out there as well because they, you know, it's cheap, nasty metal. And that's why a lot of people go to using lost wax brass castings.
Yeah. When you're spinning in the machine, how long do you spin it for?
If it's standard procedure, you set the thing for about 1.5 minutes, 2 minutes, somewhere in between there. You've got a timer on the side of the casting machine and an on-off button. And I usually spin it for about 1.5 minutes to up to 2 minutes. It don't really matter what you're putting in because it gives the mold a little bit more time to cool down. You know, because as soon as you pick the metal out of the pot, it's starting to cool. It goes through the air as it goes into the mold. It hits the mold that is cooler than that is, and it's getting thrown up the mold, and it's cooling down as it goes. So that's how that works.
Right. Several people asked us, do you cast brass in your machines?
No. Brass melts at something like 1100 degrees, and you've got to have what they call a crucible, which is a metal
It's a lot hotter than you use.
Blooming hot, yeah, like a blast furnace, because you've got to get brass really hot to get it molten. My pot here goes up to 750 degrees, I think, because I can actually melt aluminium, but I can't get anywhere near the temperature to melt brass. No, that's a different process altogether.
So what temperature do you normally have your pot at?
Somewhere between 350 and 400. Mm-hmm. And it sits there and ticks over quite happy all day. It takes about 40 minutes to heat up. And once it reaches its temperature, it just clicks on and off, and it stays there. I mean, if I'm, shall we say, running the molds and they're all starting to get a bit warm, sometimes I'll turn the temperature down to about 300 because the molds are starting to get hot. And that's the time to say, time to go and have a cup of tea and leave it.
Do you turn the pot off overnight?
Yeah.
So you don't run it 24 hours a day then?
Yeah, when it's finished, when you finish your casting, you have a sweep round, sweep up all the bits that have flown everywhere, all the dust. And what I normally do last thing is I get hold of a bar of metal that I put on the casting, on the pot to heat up. And then last thing, put that bar in, give it a stir, and you'll find that all the dross comes to the top and you'll get like a little island in the middle of it. You just go around with a ladle, scoop that up, drain out the metal, give it a shake, drain out the metal, and tip the rubbish out. Because like the antimony and stuff like that is all like brown, comes out like a bit like soil. So that when you go in the morning, you switch the machine on, takes about 40 minutes. When it reaches its temperature, you've got a nice clean surface of metal to start casting from.
Right. Well, somebody did mention that obviously you keep on recycling and recycling, putting stuff back into it. Does that process itself cause contamination?
Well, in the process that I'm, you know, the way I do it, if you're running sort of 8 molds, you're going through a bit of metal. You know, I can go through 4 bars of metal in a day. So, you know, in the process, you're keeping it stirred and you're adding new material all the time. And as I said, sometimes just to top it up, I'll put in a bar of Ka, which has got a lot more tin content in it, just 1 bar. So I got 3 of 34.5 and 1 of Ka, so that it just ups the tin content, and it keeps the metal nice and clean. And every now and again, if you just when you put a mold in, a bar in, and give it a stir, what dross is in the thing will come to the surface and just scrape it off, and out it goes.
And you mentioned earlier that what you do is you cast a mold, lift it out, cast another mold, lift it out, and do that several times over. How long do you leave the molds cooling before you actually take the bits out of it?
Well, again, this is one of the things that, you know, if you take the mold out of the machine and then strip it out straight away, you won't be able to touch them castings because they'll be just too blooming hot. That's why I like to run 6 or 8 molds, different molds. You have a stack of them and you go round in a circle. You pick up a mold, you put it in the machine, you switch it on, you pour your metal in, then you go to the stack of the mold that came out before that, and you've probably got 3 on the table that have got metal in them. And the top one, by the time you get to it, number 4, because you put the next one underneath, you can strip that one out and it's not hot enough. It's not so hot that it burns your fingers. And so that by the time you've done that, stripped it out, you've put it on the windowsill, you've talcum powdered it, clapped it out, you've put it on the bottom pile next to the casting machine, and you've probably got 4 molds on top of it. So then the machine clicks off, you open the lid, you take that one out, you pick the next one up to the right, put it in the machine, you start the process again, and you go round and round and round in a circle.
I see.
I mean, sometimes we used to have, when Keith used to come up here with me, at the end of the day, we used to have what we called a hot push, where we had a few bits and pieces, and we used to run one mold, 2 or 3 times until we had a plastic food container that the missus, I don't know, she had mushrooms or bloody tomatoes or something in it. Keith managed to empty a mold into it, and it melted the bottom of the plastic tub. He picked it up and all the castings went all over the floor. And we thought, that's not a good idea. So that's why we got to leave them to cool down a little bit before we chuck them in a plastic container.
When you do your molds and all the metal goes into it, how come you don't get seams?
Seams?
Seams on them, on the castings.
This is again, you see, you can get flash, and that's down to the pressure. And if you saw when I showed you the inside of the casting machine, you've got the bob weights that fly out. When the machine spins, the weights fly out and it clamps the mold together. And that's what adjusts the pressure. And if you haven't got enough pressure, it'll leave the mold that little bit slack, and it'll force the metal out the join between the 2 rubber molds. And that's how you get flash. And if you get that, then you know that you haven't got enough pressure. So you either turn the speed down a bit, because it might be spinning a bit too fast and it's forcing the metal out, or you just up you get hold of one of them weights and you wind it up or out a little bit so that you get more clamp pressure so that it holds the mold together so that you don't get the flash coming out the side. The other thing is that you can get is what they call step. You'll get 2 bits, they won't be quite in line, they'll be like that instead of flat. You get like a step in it and you get 2 halves. And that's usually down to poor metal and poor rubber molds, actually, where things can move about. They do move about sometimes, and sometimes you can do a load of casting and you can't even see the part line. But sometimes you will see the part line. And this is where you've got to be careful sometimes when you're putting a master in the mold. You've got to make sure, it's like old Chris got Chris Smith at Invertrain. He's got a very nice platform canopy support, a column, all fluted. But at the top, there's a U shape that the roof strut sits in. And I've got to use an insert for that, because if you put it in sideways so that the 2 sides are sticking up, you'll get a part line up either side of it. But if you lay it down flat and put an insert in it, the part line goes round the edge. You can't see it. So this is one of the things that you learn of once you've got a master, how you put it in the mold to get the best out of it.
Thank you, Andy. Well, at this point, I'm going to pass you back to Jackie, if that's all right, Jackie.
Yeah, you've got me started on inserts now, because that's quite timely. One of the questions that came in before the evening was, when do you actually make the inserts to go in between the horse's legs, for example? You showed us how you actually cast some horses and some deer and things in the film, and you were pulling inserts out. So when do you make those, and what are they made of?
Well, they're made of exactly the same thing. They're made in exactly the same rubber. As I said, when you get a blank, sometimes you sacrifice a blank because these are all in, I don't know whether you can see. You see there's a line there, look.
Yep.
There's about 5 or 6 of those lines, and you can actually peel that apart, and you can peel the layers off. And that's the mold for the dogs. And you can see there that nearly all the dogs have got an insert.
Yep.
And you'll see that they're all different shapes. So that you don't go around trying to figure out which one goes in what. You make them look a different shape. So you know that one goes there and that one goes there. And basically all it is, if you've got a horse, I mean, a horse isn't too bad because these horses are made in halves. So you've got half a horse.
Yeah.
And the same with a cow, you've got a side of beef. But when you've got something like those stags and the horses that I've got and these dogs, because you've got 4 legs, if you like, if you did that without putting that in there, you'd have a hell of a job getting that out without breaking the legs off.
Yeah.
You can imagine you'll have to bend that out and you'll just snap the legs off. So you cut out a piece of rubber from one of these molds to whatever shape you want. You get hold of the dog and you just push it in between the legs, raw rubber. And then when you make the mold, you put the dog, for instance, in the mold with the piece of rubber between his legs. Then you just carry on and vulcanize it in the normal way. And the insert will vulcanize the same as the rubber mold will. But what you've got to make sure is that the rubber insert doesn't vulcanize itself to the mold. So when you do that, you've got to make sure that the insert has got a lot of talcum powder on it. So you've got a barrier between the two. And when you put it in, it's sitting on talcum powder. It will vulcanize because it's under pressure and it's at the temperature, but it won't vulcanize itself to the other part of the mold.
I see.
Now, the other thing you can do, if you've got a really bloody horrible shape, you can actually make an insert which is fixed to the inside of the mold. So you actually put a piece of rubber inside something, if you like, where you want it to go, but you don't want to use it as an insert because it's probably underneath. What you've got to do then is with cellulose thinners, if you clean the area with cellulose thinners and clean the bottom of the piece of rubber that you want to fix, you'll find that they go very sticky. So you put the piece of rubber onto the 2 pieces of cellulose thinner and it will stick. And when you vulcanize it, those 2 pieces are vulcanized solid and you can't get them apart. So you can do it that way, or you can do it the way with the piece like the end of Chris's column. You get a little piece of rubber that sits in the end. When you take the thing out, just pull the thing out, you've got a V already formed so that it will come out the mold.
Very good.
Yeah, no, that's really interesting to watch that. And
Yeah,
I guess a similar question really, but you also showed us in the film that some of the very fine things, the handles and other fine components, you'd put a bit of wire in there to strengthen it. So when do you get the wire in? How does that get inside the white metal?
Right.
Is that laid into the mold at some point?
There's one there, look.
Oh, yeah.
That's the base of a jib for the crane. The jib comes out here.
Yep.
And you've got 2 little pins, one there and one there, which it pivots on. So that when you make that pattern, you make the pattern with the brass pin. So this is all made of brass and the brass pins are sticking out here. So when you put that in the mold and vulcanize it, take the pattern out, you've got the hole where the brass pin was.
Mm-hmm.
So that when you want to cast that, you literally just lay a piece of wire across there, put the mold in the casting machine, and it'll cast around that piece of wire.
Yep.
So that when you take it out, this is all white metal, but you've got brass pins sticking out both sides.
Yeah.
It's came with things like traction engine axles and all them sort of bits and pieces. One of the real pain in the bum to cast is blooming smoke box doors, because smoke box doors have got the bar between the two hinges.
Yeah.
And I mean, I've done quite a few, and people say, "Oh, I can't get them bloody things to cast." I said, "Well, no, you won't." So what you do, instead of leaving it, you just put a piece of brass bar in the mold and then cast it. So when it comes out, you've got all the white metal bit, but the bar is an actual brass hinge. It's already cast in the machine. And I mean, I've got a lot of things like that that you use for, you put bits of metal in and cast, like my gas lamps. When I was doing the gas lamps, you had a brass tube. So you get a brass tube, and it's got probably a 1 mil hole in the middle of the brass tube. So you get a piece of 0.9 mil wire, and you push the wire down the hole. You put the whole thing in the mold, the brass tube, inside the gas lamp, and you cast it. And when you take it out, the tube's in the middle and the gas lamp's cast round it. So then you pull the wire out, then you can feed your wires down for the bulb.
Oh, yes. Yeah.
And the other ones that we do, the other gas lamp one, we've got a copper tube. The actual stem of the thing is a copper tube. So that when you cast that, I think there's 3 in a mold, you cut 3 lengths of copper tube, you put the 3 lengths of copper tube in, put the top on it and cast it, and it comes out with the base already cast on it and the bit sticking out the bottom.
It's very clever. I mean, I know you've had years of experience, but, you know, hearing you talk about all those clever bits is really fascinating, actually. It's really good.
Well, it's the sort of thing that, I mean, I don't know everything about this. I don't think I should ever will. I'm still learning now. But it's things that you pick up over a period of time. You know, somebody will say to you, "Can you think you could cast that?" And you think, "Yeah, I can do that." And you think, "Oh, that's going to be a bit of a pain in the bum." And you start doing it and you think, "Well, I ain't going to cast like that." And that's when you start thinking about different ways of doing things, of how to put things. One of the things that really got me was a bloke had a shutter. It was like a sloping vent for was it a diesel? I'm damned if I know. I think it was for a diesel loco, and he'd been to about 2 or 3 people, and he just couldn't get these sloping shutters to cast. And he sent me over some, and I looked at them, and I thought, "Oh, that would be a pain." But in the end, what I did was I made an insert for him, but the insert was underneath, so the shutter laid on the top of it. So that when I took it out, all I had to do was take the insert away, and you had the shutter that way. You turned it round, and you could see what he was wanting. You know, you had the end of the shutter to work. But it's just a case of sitting there and thinking about it. You know, thinking, "Well, how am I going to do that?" And you just learn these things over a period of time.
That's quite timely to talk about that, actually, because one of the questions we had was, what advice would you give to somebody who was wanting to design a kit from scratch? What would they have to do if they had an idea and wanted to make it into a kit?
Well, basically, if you're going to make it into a kit, somebody comes along and says, "I'd like to do a kit of a horse box." And you say, "Right, okay, horse-drawn horse box. Okay. Do you know where one actually exists? You know, a full-size one. If you can find one that's actually still in existence, and you go along and have a measure of it, take a load of photographs underneath it all the way around it so you can see where all the bits are. Because it's no good just taking one photograph of the side of it, because, you know, you don't know what's underneath it. I mean, I spent many happy hours crawling about under all sorts of blooming things, taking photographs underneath. And like I said about chasing cows around the field, trying to measure the damn thing. And you get to the stage where, right, I want to make a mold of that thing over there. You go and take some photographs of it, and then get yourself some really good measurements so that you know where, you know, the size of the axles, the size of the windows, the doors, the tow bar, how thick is the bar, how big are the wheels, and you make yourself a little, I mean, mine were just sort of hand-drawn diagrams with measurements on them. And you just work through it and say, right, I'm now going to make the 4-carriage. The 4-carriage, right, where's the photographs with the 4-carriage in it? You get the photographs out, you've got the measurements, and you just sit there and make that out of your bits of brass, and you end up with a pattern. And that really, I mean, there's 2 or 3 ways you can do it. I mean, nowadays we've got this 3D printing, and I've had 1 or 2 bits and pieces made in 3D, which are a bit of a pain to make as a pattern, shall we say. I was seeing somebody was saying about lobster pots. I mean, well, actually it was old Pete Waterman. He said, I want some lobster pots. Can you make some? And I thought, no. And I said, if you think about it, it's just a net over a frame. And there's no way in the world would you ever get that to cast. Now, I know somebody does do lobster pots, but they're solid. And it's just got the detail on the outside of where the netting would be. So dear old Pete, he said, well, how am I going to get over that? I said, well, 3D print them. So that's what he did. With his fantastic machinery, he ended up producing these lobster pots, and they were beautiful, but they were so blooming fragile. The boat hand windlass for winching boats up ramps and things like that. The end of it was quite a fancy shape because it had all edges and lips and curls and swirls on it. And I had that 3D printed. The acrylic or whatever it is that they use is quite happy in the silicon mold. And you can use that as a pattern. The majority of things you can either, if you've got a little bit of skill with a bit of scratch building, you know, it's quite easy. Everything's 7 millimeters to the foot. So you just measure it all up and you end up with a kit of parts, and then you go to a mold maker, make your molds, and away you go. But it's critical to get good photographs of all round it, get good measurements, and then just sit and make your patterns from that. But you've got to, if you look at the shepherd's oak, you've got to take it apart. So you make it in parts, if you know what I mean.
Mm-hmm.
You said about running around a field. We did get one request for the future that next time we're running around a field and trying to chase down an English shorthorn, they want it videoed, please, because they think that would be a very good evening with to watch Andy charging around a field.
But then cow didn't want to know. I mean, animals are very, very peculiar because, like I said last time about geese, somebody said to me, I want some geese. Oh yeah, I know where there's some of them. These damn great white farm geese. God, there's some stroppy creatures there. You get anywhere near them, no wonder they're blooming good burglar alarms. But you get up close to one and you think, hey, blooming big they are. They're up past your waist.
Yeah.
And, you know, you're saying, stand still a minute while I measure. And this thing's looking at you as much as say, you come any closer, I'm going to have you. So you have great fun measuring animals and bits and pieces. So some of it is a little bit of, shall we say, artistic license, but you've got to get it somewhere near. And then it's sculpted out of milliput, which is quite therapeutic exciting because, you know, when you start, you make something and you think, God, that looks like a bloody cripple. What have I done to that? And you chuck that away and start again until you get it to look something like what you intended it to look like in the first place. But shall we say, animals are always difficult because you've got to get some sort of scale, shall we say. If you're doing things like timber pole wagons and carts and God knows what, they just stand there and let you measure it. But animals don't stay still.
Yeah, I wouldn't like to chase around after geese or swans, that's for sure. I've got one last question. Somebody's asked if they damaged or lost a component, can you cast individual pieces? If somebody needed a single bit from a kit because they damaged it, can they contact you to get that piece?
I mean, that's never ever a problem because, I mean, I don't know where if you look around the casting shed up there, there's castings everywhere. All them boxes up on the shelf are full of castings. Because what I do, I mean, when you start, as I said, when you start casting, the molds are cold. So the first probably couple of spins when you spin it, you know, you won't get a complete kit out because what happens sometimes is you're casting away, and you're doing all right. And all of a sudden you realise that there's one bit in the mould that hasn't cast. And you think, oh, wonder where that bit went. So all the moulds that you've cast are no good to you because they've all got one bit missing. You've got to start again. So a lot of the time, if you're doing things like the lathe, which has got a lot of little bits in, I usually do 2 spins of the lathe, and I know that all the bits aren't there, but I keep them on the bench so that when I'm casting, if one bit doesn't cast, I just go to the one that I've done before and take the bit out of that, so that I make sure that the kits have got all the bits in. And I mean, I do get people that said, I'm terribly sorry, but I tried to solder it and I've melted it. And I said, well, it's not a problem, just let me know. And I've usually got spare parts for nearly everything here. You know, people have ringed me up and they say, have you got the 2 front wheels for the horse bus? Yes, I can send you the 2 wheels for the horse bus. I've always got plenty of spare bits. And I normally say to people, you know, especially if you're doing something like a traction engine with all them bits in it, you know, if you break something or you lose something or it's not, just let me know and I'll replace it for you. That's not a problem.
I think white metal soldering is an art in itself, and I know we've got your video already of how to do white metal casting, and that's coming back by popular demand to the show at the weekend.
Yeah.
And so if people have any doubts about white metal casting, it's well worth watching that video, and it's available on our YouTube channel, and it's also going to be at the show at the weekend. Talking of which, we were asked what your company name was. It appears that there's somebody who is out there who doesn't know you that well, Andy.
Really?
I think you've got a mug there that gives them an idea of your company name.
There you go.
Duncan Models. Yeah, so if anybody wants to just do a Google Duncan Models, they'll find the website.
Yeah.
And I think I've covered all the questions I had. Have you got any more, Tony?
No, I think I highlighted a couple that I remembered.
Yeah, no, it's been really, really good. And thank you very much for rerunning it. I just want to take you off spotlight, if I may, Andy, and just show a couple of slides so that people...
Before you go, I was just going to say to people, you know, when I started, and I know a lot of people are the same, they say to me, how did you start all this? And I mean, when I first started soldering white metal, I didn't call it soldering, I called it blobbing. That's what I used to end up with. And I used to think, what am I doing wrong? And you go off and you learn. And over the years, you know, I can solder transfers on. That's what I tell people. Is I'm that good, I can solder transfers on. But it's only the sort of thing that you learn. And it's the same with making molds. When I first started, it was an absolute mystery to me. And I used to think to myself, how the hell do you do that? And over a period of time, there's always somebody out there that'll help you. And there's always somebody that's pretty damn good at it and you can learn from them. And that's what I like doing, you know, and this is why the shows are so important to me that, you know, my customers, they know full well I'm going to take the mickey out of them and we have a bloody good laugh. And it's, well, you know what it's like when we're at a show. And that's one of the things people say, how do you do that? And say, oh, you just do this, that, and the other. And it's brilliant. And that is one of the reasons why, you know, I got into all this. I just wanted to say that if people want to learn, you know, it's not that difficult. I've always said it's very, very simple for somebody to do if they know what they're doing. If you don't know what you're doing, there's always somebody that'll help you.
Yeah.
Especially in the guild.
Yeah.
That's very true. I learnt white metal soldering from you at an exhibition, sat there and you taught me.
Yeah.
And I won't forget that. I learnt a lot from you and it's very, very good.
Yeah.
I'll just take you off spotlight for a moment and then just share my screen, if I may, and just literally show you a couple of slides of what's to come. So if I just bring this to the start. Everybody see that?
Oh, yes.
Okay, so these evening withs were actually an idea from some members who said it'd be really nice, it was after the first show, if we could have something like this every month. And clearly we can't do a show every month. So the idea of having a modelling topic every month for an evening so that people from overseas could join us, and it may be morning for them or afternoon for them, but we started in January. Andy has just obviously taken us through our second evening with, and the third one is Robin Taylor, and he's going to be teaching us how to actually make a coach. And that's from a kit as well as from bits of kits, because sometimes you pick up bits of kits and what else do you need to actually make it a whole, what materials a coach is made from. So that's going to be a really good evening on the 26th of March. And by the time you watch this video, you will find that you can register for that session in March. And if you go to the very front page of our website, there's a picture of Robin like you see now, and then you'll see a little link that says register here. It's always the 26th of the month. It'll vary in terms of weekday, which is what people wanted. And obviously it's open to as many members. We've got a license that goes up to 500 so that we don't actually have problems with it being too full. And non-members are welcome as well for a small fee of £2. So do make sure you look out for all of the sessions. We won't have one in December, but there'll be one every single month except December. A reminder that on the 6th of March, we've got our virtual model railway show. That's got lots of layouts, demonstrations, some live sessions, which again, you'll join by Zoom, displays of lockdown models, a large array of traders with website interest, and some of them doing special offers on the day. And certainly that's going to be running for a whole month. So if you can't see it on the 6th of March, everything's being recorded, and we will make sure the red light's turned on and that there aren't any errors with Zoom, so that we can make sure that everybody can see that no matter what time zone you're on, no matter what day of the week it is, it will be there, entry via the website for the whole of March. A reminder that Doncaster show is cancelled. Unfortunately, restrictions won't be lifted by the 5th of June, but we're keeping everything crossed, fingers, toes, and you name it. We're thinking that 4th and 5th of September might be possible. So that would be wonderful if we can have an exhibition at our new venue on Stafford Showground at Bingley Hall on the 4th and 5th of September. So fingers crossed for that one. And if anybody watching the video is a non-member, on the website you'll find out all the details for joining the guild. If you're a non-member and you're paying £2 a month for the evening with, that's £22. So why not join for 28, and you'll get all of your gazettes, the discounts at shows, a huge amount of information on our website, the wiki manual, which is fully searchable, and a huge amount of networking and support, which Andy's mentioned. So I hope that you've enjoyed this video. We'd love some feedback from you. So once you've watched the video, if you want to get in touch with me, that would be perfect. I'm just going to come out of screen share now. And the only thing we're left to do is say thank you very, very much, Andy. You did a fantastic job with the video, which we watched in the casting shed while you were on your own there. You did a fantastic job on the 26th of February. And I have to say, you've done a great job again tonight with the rerun. I'm sorry that you had to do that. Technical glitches happen. There's nothing we can do about it, and Zoom apologised. And Tony, thank you very much for joining us as well. So thank you to everybody who watches the video. We hope you enjoy it, and we hope you'll attend another evening with in the near future. Thank you, everybody. Well done.